Hi everyone! In this video, I'm going to be looking at the relationship between marginal revenue and elasticity. And specifically, I'm going to derive this relationship here, that marginal revenue is equal to the price multiplied by 1 plus the inverse of our elasticity. In the next video in this series, I'm going to take a look at an example where I look at how to interpret this relationship. So I will link to that video when it's ready in the description. Alternatively, you can have a look at the elasticity playlist on my channel if that's something you're interested in. Right, so to prepare, I'm just going to write out some relevant formula. We have our elasticity of demand, which is dq dp times p over q, so the derivative of quantity with respect to price times price divided by quantity. Our total revenue is just price times quantity. Our marginal revenue is the derivative of total revenue with respect to quantity. We're going to start the proof with our marginal revenue formula, and I'm going to start by substituting in price times quantity for our total revenue. So we get marginal revenue is equal to the derivative of price times quantity, or with respect to quantity. The thing to note about this derivative is that the price itself is a function of quantity. So sometimes we actually write the price variable with a q in parenthesis right after it, and this just means that price is a function of quantity. So I can write dp open brackets q close brackets times q with respect to q. You might have something like this in your notation at home. Now you can see that this relationship obtains just by looking at our demand curve, where clearly the price that the firm can set for their product is dependent on the quantity that is being produced. In my notation for this video, I'm not going to use the parentheses just so it can be neater, but you can definitely leave it in. The point is that we need to recognize that price is a function of quantity, because price multiplies our quantity variable, which also itself is a function of quantity. So Q is a function of Q. And this means that in order to take the derivative of this multiplication, I'm going to need to use the chain rule. Now to use the chain rule, we're going to take the derivative of our first function with respect to quantity. So our first function is price here, so dp dq, and we multiply it by the second function, which is just q. And then we add to that the derivative of the second function with respect to q, so dq dq, and we multiply it by the first function, which is just p. In order to simplify what we have here, we can note that dq dq is just equal to 1, since quantity moves at a 1-to-1 ratio with itself. So we're left with, well, dp dq times q plus, well, p multiplied by 1, so just p. Now you can see here almost dp dq times q, that first term, it looks very similar to our elasticity of demand, which is dq dp times p over q. What we need to recognize is just this. If we think about the inverse of our elasticity of demand, we have 1 over epsilon p. Well, this is 1 over dq dp times p over q, which is actually equal to dp dq times q over p. So taking the inverse, we just swap the numerator and denominator values. And I hope that you can see that the only thing that we're missing in order to turn that first term of our derivative into the inverse of our elasticity is just a price variable on the denominator. And that's exactly what we're going to try to do. We're going to try to manipulate the first term until we get a price variable on the denominator, and then we can introduce 1 over the elasticity, or that inverse of the elasticity, into our equation. And I can do that by multiplying the whole first term by p divided by p. This is a completely legitimate move because p divided by p is equal to 1. So we're introducing the new variables, but we're not changing the value of the term. Now I'm going to expand this in a particular way, which will make everything clearer. I'm going to take the numerator p out the front, and I get p times dp dq times q over p. I've put that denominator p just under the q variable. Then of course we have plus p. Hopefully you can see why I've done that. It's to get that inverse of the elasticity variable in here. I've just outlined it in green. I can rewrite this price times 1 over the elasticity plus p, and I can also factor out p2. So I get p times 1 over the elasticity plus 1, and we usually rewrite that p times 1 plus 1 over the elasticity. The reason why we usually write it like that is because our elasticity is negative, and so when we evaluate the right hand side of the equation, it would be price times 1 minus some value. And that's it. That's how we get that relationship between marginal revenue and elasticity. So I hope that helped. If it did, please like and subscribe. Otherwise, I hope you guys have a lovely day or night.